thanks for joining this session. And I started this AWS certification bootcamp because I had a few interest from students in terms of this bootcamp for a solution architect associate. Uh, it might seem a bit tricky, right? Because I've only allocated, I think, 20 to 25 hours for this bootcamp, but I think 25 hours is enough for preparation of for this certification. So in this presentation, I'm going to cover what are the AWS services and a bit of understanding on AWS Solution Architect Associate. So, just a brief introduction about me. So, I have been into training as an instructor, for at least 9 years now. I have around 6,000 students on Udemy for courses related to DevOps. I also teach courses related to telecom, and these are the links. This is my YouTube channel. In case you want to subscribe, you can go ahead and subscribe to it. You can go to my website as well, mohitkr.com, which has few courses like Introduction to Cloud Computing, etc. And you can also go to the Udemy page. So on my website, you can see all these free, you can say, courses. The Telecom Upskill Bootcamp was basically a bootcamp that I run last year, and then there is the cloud computing and cloud native fundamentals you can say course. There is a markdown essential course, and then there is the AI bots as personal assistant. So these courses are free. So if you want, you can go ahead and subscribe to these courses. Go through those courses and let me know how you find these courses. Now, what is the agenda for today's session? So in today's session, we are going to understand what is AWS Solution Architect Associate exam. We are going to have a very quick overview of cloud computing, and then we are going to understand what are the some popular AWS services, and we are going to do it in a logical way. So this would be the agenda, and then we can have some question and answers. You can say going to the end of the course. In case you have any questions, you can also use the questions tab on the left to ask the questions, and then it would be visible for others as well, and I can answer them as well. So let us try to understand what is the AWS Solution Architect Associate exam. For this, we need to understand what is the primary job role of solution architect. So solution architect basically performs the key aspect of converting business problems or challenges into a technical solution, a technical feasible solution, I should say, which can convert into a business operations or business opportunity. And then the second task of a solution architect is to optimize the business process. So this is the you can say general a very high level overview of what solution architect does. And if you look for competencies of solution architect, you will see all these terms like this is related to compute, right? And cloud as well. So you will have cloud computing, you will have integration, strategy, management area, etc. So these are the some of the, you can say, key competencies of a solution architect. Now, when we are talking about AWS Solution Architect Associate, these are the key consideration, and this is from the AWS Well architected document, and I'm going to talk about this in the bootcamp. This is very important for your certification, but AWS specifically, has some consideration, or you can say some guidelines in terms of how we should develop solutions. So they have divided these consideration into several pillars, and this is called as AWS Well Architected Framework. It has, for example, operational excellence pillar. So operational excellence means if you are developing a system, right, it should be efficient, and you should be working to continuously improve the process or the system. Then you have security pillar. Security means your system should be secure. You have to manage the permission on the least access basis. Then you have reliability pillar, which is basically in case of any issues, your services should not go down. It should be reliable. So you should have a business continuity process, and you should have a way to recover from failures, and you should have a way to recover from failures, and you should build resilient systems. So resilient system means in case there is an outage, right, your systems are still able to serve. And then you have performance efficiency. To improve the performance continuously, you should have some sort of monitoring, right? You should not be going down in terms of efficiency, so you should have optimized resources, and you should also monitor the performance. And last is the cost optimization pillar. Now this is FinOps and cloud cost management, which I will talk about uh, in the course. So what happened, with cloud, the cost has become an operational expense. So operational expense means you have to pay it on a daily basis. So suppose a person is using the cloud in an you can say in very careless manner, they can get a huge amount of bill. So you should have a policy to manage your cost. You should have a policy to identify the wastage, and you should have a policy to optimize your cloud cost resources. So this is called FinOps, or financial and operations, which is also part of you can say complete life cycle of DevOps. And then you have the sustainability pillar, which is you reduce you can say environmental impact. You have a shared responsibility model in terms of other businesses you are working with. So these are the operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability pillars, which are part of the AWS Well architected framework. So this means whenever you are going to create a solution, you should always keep these six things in the mind. All right. So what type of solution you have to develop? It depends on whom you are working with. So AWS, and irrespective of AWS, any cloud vendor today is part of any industry. Some of you might be from telecom, some of you might be from other services. So in your industry, how you are going to implement those cloud services, it is that challenge that you have to solve as a solution architect. All right. So now when I talk about key objective of this exam, right? What you should be uh, you know keeping in mind when you're preparing for it. So first and foremost, every question that you are going to answer, right, has to be on this foundation. If that scenario that was given to you is a cost effective, resilient, and efficient solution with the AWS services. So to have an expertise on this, you should have a complete overview of available AWS services. So what are the available AWS services, right? What services are used for what purpose? So for example, we'll see what are the various services in this today's session, and we'll also see what services are used for uh, what specific use cases. Then there is a best practices of each service. For example, uh, I will give you an example that you should put your compute only in a private subnet. We are going to talk about this in today's session. But for every service, there is a best practice. And this best practice, how would you know? When you try to, go to AWS documentation, or you try to implement it on your own, you would know these best practices. And these are very general in nature, very logical in nature. It's not, I would say, something which you require a huge expertise on, but this is a general nature practice. Then how you can manage the cost. As I mentioned, cost has become a daily job. So managing the cost is very important. And how to make system resilient or fault tolerant. So these are some of the key objectives when you are working towards preparation for your AWS Solution Architect exam. And now if we talk about the exam itself, so it has two types of question: multiple choice or multiple response. So multiple choice means uh, if you have uh, you can say a radio button in your answers, this is called a multiple choice. And if you have a square checkbox, this is a multiple response. It would be mentioned in the question as well: two responses or three responses, etc. So this means either the for multiple choice you can have only one correct response. In multiple response you can have two or more correct responses. Yeah. I think most of you would be aware of these type of you can say exams where you'll have either multiple choice or multiple response. Now, there is no penalty for guessing. So, in case you don't know any answer to any question, the best way is to remove the you can say the least probable answers, and then go with the which is the best you can say best matching to your that phase of mind, right? And it includes 65 questions in total, but 50 questions are the one which will affect your score, and 15 are the one which are not scored. So most of people think that we get scored for all the 65 questions. No, only 50 questions are scored one, 15 does not have any value. So you don't know which questions would have any value or not. It is internal. And these 15 unscored questions are used by AWS internally to identify some things related to what is the performance of the candidate, right? It might also be used to eliminate some cheating in terms of dumps, etc. So these 50 questions you won't know which are the scored one or which are not the scored one. So in the once you are done with the exam, you will get either you are passed or failed, and you will get a detailed scorecard after and only you have you close the exam. So it's not immediately shown on the screen, right? So this is the kind of brief overview of AWS Solution Architect exam. And what is the best way to clear the exam? First and foremost, you need to book the certification. In case you feel confident, uh, I would recommend you book it 1 month 1 month from today, or 2 months from today, depending upon how much time you can allocate, right? Then you can create your own AWS account with free tier. It's very simple. I can show you how to do it at. Then you have to use some AWS services to gain some knowledge, and you don't have to do all the AWS services. There is a free tier. Specifically, whatever is in free tier you can use to deploy it on the cloud, and you won't be charged for that, right? Once you have bit of hands on, right, it would be easy for you to understand how things work. Then I'll have a study group. You can ask questions. I would be there to answer. Stick to the schedule. If you can allocate, there is around 10 to 12 hours of study per week. I think you can easily clear in one month. uh, Use some practice exams. So I've reached out to Tutorials Dojo. Their practice exams are pretty good. So I can also provide some coupons in terms of Tutorial Dojo, and they can, you can use those for practice exams as well. And then once you have the confidence, you can, attempt your exam. So once you book the exam, you can reschedule it 2 times with Pearson. So I would recommend, to just book the certification, for example, 1 month or 2 months. And then in case you feel, okay, I'm not confident enough, you can just reschedule it later. So this was about, you can say, the AWS Solution Architect exam. Now let's come to the topic in terms of the AWS services, right? We'll start with the cloud computing, a quick intro. And in cloud computing, we have the NIST definition of cloud computing, which is the general accepted definition. And in case somebody asks you in an interview, right, what is cloud computing, you can just mention this definition. If this seems very, you can say, cumbersome or very long, right, you can always mention the 543 model, right? So basically, cloud computing is defined by a 543 model. So 5 essential characteristics. This means any cloud computing service provider should meet these 5 characteristics. There are 4 deployment models in terms of how we can deploy a cloud. And then there are 3 service models in terms of what services can be used and what service category it comes into. For example, first and foremost is on-demand self-service. So for cloud computing, to use the cloud compute anything, for example, compute, right? You don't go to someone and fill a form and ask them to, provision resources, for you. You can go to the console or command line, whatever you prefer, and you can do it on your own, right? It is always available on network, whether it's a private cloud or public cloud. It is always available on the network. For private clouds, it's available in the internal network. For public cloud, it's available over the internet. Then there you have resource pooling, and that's how the cost of cloud is reduced. So think of it, AWS or Amazon had to build their own infrastructure to serve their e-commerce section, right? So they thought, they had an idea, okay, we have this unused compute, unused services with us, what we can do of it. So they started to rent it out in terms of cloud services. And that renting out of services is only efficient in case you have reduced cost. Okay, suppose I'm getting something of $1,000, right? And if I can avail some similar solution with $100, I would always prefer that solution, right? And with the help of resource pooling, what would happen, if you have a server, for example, you have 16 CPUs, you can give one CPU each to 16 people, right? And what you can do is you can charge them on monthly basis on the 16 CPU. So what happens with resource pooling, you are able to reduce the cost and make it much more affordable to all the people across the world. And that's why cloud computing is so much popular. Then you have rapid elasticity. So elasticity is a very important term in cloud computing. And in case you will talk about AWS, right? Some of the services are, or most of the services which are infrastructure related will start from Elastic, right? For example, Elastic compute, then you have Elastic Cache, etc. So elasticity means, suppose in a graph, I have your time and I would mention demand, right? And in the another graph, I will have resources on the other axis. So what you can do, suppose over the time your demand is increasing like this or reducing like this, your resources should be able to, so suppose you should be able to increase or decrease the resources with respect to the demand. There should be a gap, obviously, to have a surge of or sudden surge of traffic, but you should be able to increase or decrease the resources depending upon the demand. So this is termed as elasticity. So elasticity, think of, in chemistry we have two type of elements, right? Plastic and elastic. So plastic is which if you expand, right, it will retain its shape, it will not come back to its shape. Elastic is anything which you, if you stretch, right, or deform its shape, it will come back to its original form. So elasticity means you are able to move up or move down rapidly. And then it's a measured service, just like electricity at your home, right, which is a utility. Cloud computing is also a utility. It means you pay for what you use. Until unless it is a measured service, it's not a cloud computing. All right, so these are the characteristics of cloud computing. Now cloud can be deployed into four ways. One is the public cloud, for example AWS. So AWS is a public cloud and it is available to anyone. Anyone can go and create an account and use it. The second is private cloud. For example, I want to build my own cloud. I don't want to give access to anyone. I can build private cloud. So you can use either OpenStack or VMware to create your own cloud. Then your third option is community cloud, where what would happen? A few organizations can come together and build their own cloud, and use give access to the other organizations. For example, government of a country, right? For example, government of Australia creates their own cloud and ask all the department to use that cloud. So that would be the community cloud. And last is the hybrid cloud, which is the combination of either of any three types. So for example, we use public and private or private and community. It would be a hybrid cloud. So any questions still here in terms of what is deployment models or what is the essential characteristics? I don't have anything on the questions tab, so I will continue. The last and the most important part is the service models. So we have infrastructure as a service, platform as a service, and software as a service. So I will explain all this with in the next slide, but think of it, it is how we are going to, what type of services we are going to use in the cloud. Now, let's talk about this cloud provider model. So if we talk about cloud provider model, for example, we have cloud service provider, for example, AWS. So AWS has built some services and we are the cloud consumer, right? So cloud service provider is an organization that provides IT resources in form of cloud services, and we are the consumer and we are using these service provided by the cloud service provider. And there is a formal agreement. So whenever you sign up, there is a big doc, document that you have to accept terms and condition. That is a formal agreement on how you can use the cloud. So now let's understand the service model. So in any system, if we are going to deploy, we'll have following components. First, we'll have infrastructure, which will have processor, disk, your network, and some sort of memory, random access memory. You will have an operating system on top of it, either Linux or Windows. Then you will have middleware. You will have runtime libraries, applications, and data. Right? These are the components of a system. So suppose the infrastructure is managed by cloud service provider, for example, AWS, and everything else is managed by you. This is called infrastructure as a service. And the next thing, if till runtime libraries is managed by the cloud service provider and data and application is managed by you, this is called platform as a service. And the last and the easiest one is everything is managed by the cloud service provider. You only have to use and manage your data. This is called cloud service. This is called a software as a system. So I can explain you this all with a simple analogy. For example, you are going to a new city, right? And you want to go to from airport to your client to visit, right? You can go and have the car rental. So you take the car, right? You have to drive your own on your own, and you have to fill the fuel. So this is some sort of infrastructure as a service, right? Second is you take a taxi, you have the car, right? You rent the car, but it would be driven by the taxi driver, but you also need to pay for the fuel. The third is Uber, where you can have a seat sharing service where you don't pay for all this, you just pay for the kilometer that you have driven, right? So this is software as a service, this is platform as a service. Any question in this example? Is it clear? All right, so let's go to the next scenario. So now we are going to take a scenario where I will explain you a step-by-step way where cloud has taken over the current, you can say, on-prem solution. So let's start with how we used to deploy, I'm going to take an example of web application on an on-premises infrastructure. So suppose there is a person who wants to build a website for a used car. So what he can do is he can create this is a static website. For static website, we need to create every car, whatever we want to sell, a different HTML page, right? Then how you are going to run that website? You need a web server, right? So for web server, what we need is a processor, or you can say a compute service. Then you need disk where you are going to store your web server files. Then you need the network connectivity, and then you need some memory, random access memory. So this is the infrastructure. On top of it, you need some operating system, for example, Linux, and then web server. So this is called a bare metal server, where you have physical resource, operating system, and application. And how it would look like, you have a server, you have operating system, and then you run a web server, which is, for example, Apache or Linux, or sorry, Nginx. Then with virtualization, what happened? You will have physical resource, and you can use an hypervisor. With hypervisor, you can create multiple virtual machines, right? For example, here we have created 3 virtual machines. Now I can, on the same server, have different operating systems and different applications. We can also, extend it with using an external storage. Now what would happen? We don't store anything on our virtual machines, so these become stateless. When I talk about stateless, this means there is no data. For example, my VM1 goes down, it doesn't impact performance of other VM, they can still access the data from this external storage. So whenever we are talking about compute or any processing capability, what we need to do is we need to make them stateless. That is, we don't store any data inside those virtual machines. We store it in an external storage. All right. So now this would something, our architecture would look something like this. So we'll have web servers. We can have a server rack where we can deploy our virtual machines, and we can have, for example, Apache or Nginx on top of it. Now, how we connect these servers? We need a top of rack switch, right? And we mostly, connect them, directly through this top of rack switch. And this is a layer 2 switch. And in the layer 2 switch, what happens? It's in the same broadcast domain. So we can create one private network, and we can use any subnet from these range, right? These are the private network subnets for in class A, class B, and class C. So we can use any subnet from this. And suppose we chose 192.168 to add addresses to our subnet. So we can, for example, for our switch, we can have a gateway address of 1.0, and we can have 1.2, 1.3, 1.4. Sorry, this should be 1.1. The complete subnet is 1.0/24. But it's in this way you can have multiple servers talk to each other using a top of rack switch. Any questions till now? In case you have any questions, just you can post it in the questions tab. Now what we need is we need to communicate with the external world. So what we need a layer 3 router, right, which would provide us access to the external world. So till now everything is going good. We have access to internet, and we can use NAT, right? Or we have to use NAT because we have the internal IP addresses, and we'll have a public IP. So this NAT can translate all these, you can say, reachability of private address from the public IP. So NAT is a complex algorithm. There is a multiple ways how it works, but think of it. You need a NAT component in the L3 networking router that can do it for you. So for example, we have a public IP, for example, 3.22.1.22. NAT can move the traffic to the internal IP addresses. Now what we do, we map a domain name. So suppose for our website, I bought a domain name xyz.com, and we map it to the public IP. Now our website is accessible on this domain name, and users can reach this website on xyz.com, right? Sorry. So we need this entry in a DNS, right? And this DNS will have an A entry. A is for IPv4. We'll map this domain name to our public IP address. Okay. This is very simple domain name mapping in DNS. Then what happens? Can we map our internal domains as well? Yes, you can. So for example, I can name my servers as server1, server2, server3, and .internal.xyz.com, and I can create entries in my DNS. So these are the specific IP address for my servers, and I can reach rather than IP address using the internal domain name. So this DNS is an external server if you are going for an internal, or you can say on-prem service, right? So I have allocated my domain name to my servers. Now what is next? Suppose I want to provide remote connectivity for my on-prem service. I need to allow office range IP addresses or whatever IP address that we use for VPN, right? And that can be done through a network access control list. So in network access control list, we can allow 22, that is for SSH, from this subnet, whatever subnet we have, and deny from all the others. Sorry. So that's it. My infrastructure is ready. I can log in remotely as well, and my website is running. My static website is running here, and it is accessible to user on xyz.com. Okay. To upload our code, how we are going to do it? We are going to SFTP our code into these servers, and we are going to copy it on all the servers, and then it is ready. Now my static website is live, but there is a problem. The problem is that if I make change to one of the files here, I need to copy this on all the files. This is what I was talking about, a state. Suppose I made changes to this server and I forgot to make changes on other server, there would be inconsistencies, right? What would happen? that suppose my server 1 is returning different type of details than server 2. So we need to make our website dynamic. Yeah. Before that, forgot to mention, we can also do some sort of monitoring. For example, this is for Google Analytics for user monitoring, how they are, visiting the website, what type of resources they are accessing, what links they are clicking. And for our server monitoring, we can use Nagios or any other monitoring software, which will tell us what is the health of our software. And as I mentioned, the problem with this approach is that it is not scalable because we are storing state of our website into the servers. So we need to scale it, and we need to make our website dynamic. So how the dynamic website work? For example, you can have car.x, car/x, and car/y. You can use the same HTML template, and this image as well as rest of the data can be dynamically, rendered from these programming languages, for example, JavaScript, PHP, or Python. So what happens, the HTML templates remain same. Your image is coming from somewhere else. Your text is coming from somewhere else. And for this, we need a database. So you can use a relational database, for example, based on SQL. There are a lot of solutions: Oracle, SQL data, Teradata, MySQL, Postgres, SQLite. So these are all the, you can say, solutions available for SQL-based database. Or you can use a NoSQL-based database. So SQL-based database have relational database type where you use SQL queries. NoSQL database means you don't need any SQL to query. They are basically JSON-based. And for example, this is Cassandra, MongoDB, CouchDB, Redis, etc. So there are two ways you can implement database: SQL and NoSQL. Then you can store your images, video, etc. into Google Drive or OneDrive or Box on the cloud. And what would happen, you don't need to store it, these big files in the servers. So this means our servers are stateless now. We don't store any data here, right? So this is stateless. So how is this page rendered? This image would be coming from the static media, and this text would be coming from the database. Any questions till here? So servers will have the back, you can say, dynamic languages, for example, JavaScript, PHP, etc. And they will run the code to fetch the static media from whatever static content hosting we are using, and this text from the database. So I'll take a pause in case there are any questions. If no, I can continue. Now, the next challenge is there is an increase in DB load. So what would happen, because if we suppose we have a high website usage, every time your server is running a SQL query, and this SQL query takes some time to, for database to process. So this can be managed by the increase of database load can be minimized by using a DB cache. So for example, suppose there is a very famous car X, and it is very popular. So what would happen? Your DB cache will create the complete HTML website, and whenever there is a request, it will just render this. So there are solutions, for example, Redis or Memcached for this implementation, which are available in the market. So it will cache all the queries that are picked out of the database, which are very frequent, and it will store that. So it will reduce the queries on the database. Now, we have solved the problem of our load on the database, but how to solve the problem of our, you can say, server? So we can have two types of scaling. We can have bigger servers, that is called vertical, or we can have multiple servers, which is called horizontal. The benefit of horizontal scaling is that it also improves availability. For example, once server set goes down, we can have some other server set running. So our architecture would look something like this. So this is your server 1, your server 2. Your router can send traffic to both of the server. There is a round robin algorithm that you can have, that you can implement on your routers. But the problem with router is that it does not know what is the status of your server. Suppose the server goes down and the root is still available, Suppose the application is only down but the networking is working, so the router will still be able to send some traffic, right? So we need an intelligent device that can route the traffic intelligently, and that is a load balancer. So load balancer would know the state of the servers and will route the traffic intelligently. So we can have various algorithms using a load balancer. Now as the traffic increases, there might be a chances of DDoS attack or DOS attack from suspicious elements. So we can implement a firewall which will do two things. It can only allow the legitimate access, and it will also prevent for a DOS or DDoS attack. So this is our final on-prem architecture. Any question in this before we start to reimagine this architecture on the cloud with AWS and see what are the type of AWS services we can use? So this, Farhan, we are talking about in on-prem, and yes, when we are putting multiple servers and database, it will increase the cost. So as and this is what happened, in case you have demand increasing, you need to put more solutions, and that also includes the cost of buying those solutions. For example, you will buy servers, you will buy the software, and then you will also need some expertise to handle that. But in cloud, this is a bit different. Any other question? Or we can start with working with cloud. So with vertical scaling, you don't have that option of, you can say, resiliency that horizontal scaling does. So if a vertical, if you scale your server vertically, you are only getting a bigger server, right? So here, what's happening? We have a server rack. If we put bigger or better compute services here, until unless we have a VM-based architecture, if a server fails, all these VM would be down as well. So the benefit of horizontal scaling is that it also provides you a bit of resiliency. Suppose this server group goes down, you still have your other server working correctly. All right, so let's get started and think of what is the the same use case in the cloud. So with this, implementation, we are going to understand what the AWS services are. So this session does not tell you how these services work, but you will have a fair bit of understanding of all the AWS services that I'm going to talk about. And I think it would be around 10 to 15 of those AWS services, which I'm going to show in this session. So just a brief overview of AWS. Uh, it provides over 200 different services on various industries, and it's available on demand with pay as you go pricing model, right? One thing to note is AWS regions. There are around 33 launch regions. So region are basically there are a group of uh, data centers. So it's not one data center in region. There are at least 2 to 3 data centers in region. So for India, we have in Mumbai, and I think the second one is in Hyderabad. But every region will have different, you can say, geographically located set of, you can say, regions, and in each regions in a different flood zone. So environmentally, there would be a different flood zone. AWS has built the data center. So in each region, there would be 3 availability zone, and these availability zone are basically a data center which are in a different flood zone. So the key term to remember about availability zone is that they are in a different flood zone and they are connected with uh, high capacity fibers. So we have 105 availability zones. And then you have the point of presence for CloudFront. This is for edge caching. Basically, suppose you are watching a video and suppose my server is in uh, my server is in Mumbai, right? My data center is in Mumbai. I'm in Delhi. So there would be a POP in Delhi which would cache all the videos. So it is easier for me to, access that video without any delay or without any latency. So that is called as CloudFront POPs or point of presence. Okay. So there are some of the services which are regional and which are some of them are global. So global are basically some of the services, for example, Route 53, IAM, CloudFront, WAF, which are available in across all the AWS regions, right? Some of them are region specific. Just give me a moment. Sorry for that. So yeah, so this is the regions. Any question in this one, region and global? Think of it. Suppose I want to spin up an EC2 instance. I need to go to a region and then spin it. However, for Route 53, it is available across all the regions. So you don't need to go inside a region to spin it up. So this is the you can say various geographical segregation. So region is in a separate geographic area. Availability zones are multiple isolated location within each region. Then there are certain local zones which you can place compute and storage closer to your end user. For this is for single digit latency. So local zones are not available on all the regions. Then you have AWS Outpost, which is basically a data on-prem service. You can buy some servers and run AWS Outpost, which would similar to running AWS on the cloud, but you can use them on your own data center. Then you have wavelength zone, which are for 5G services for edge computing. Now let's take the scenario, and I need to let's think of the same scenario and deploy it on AWS. So first and foremost, we need to decide the region, right? As I mentioned, we need to decide where we want to deploy. And I think if we take the scenario that we are going to deploy for users in India, the best region would be Mumbai, right? So we have decided our region, that is Mumbai, right? And once we have the region decided, we need to create a VPC or virtual private cloud. So what is a virtual private cloud? Virtual private cloud is basically a logically isolated virtual network. Think of it as, suppose in your home, right? You buy a new router. What you do first thing? You configure the internet IP address, the WAN IP address, or you can say DSL, whatever you are using. But for the internal network, you create a subnet. For example, you use 192.168 x.x, whatever IP address, and then you use it as a DHCP to assign IP addresses to your to your systems or to your devices, right? So this is something similar to what we do here. We have a private network subnets, and we used this 192.168.1.0. So similarly, in this case, what we can do is we can assign a IP address or IPCIDR range for our virtual private cloud. So suppose we have selected this CIDR, that is 10.0.0/16. So I'm using a /16, which means I will have the last two octets available for the host. I can use any subnetting tool and I can divide the subnet, right? And this is a simple chart in terms of what IP addresses would be available. So I'm not going into subnetting details, but think of it logically, we are breaking the complete CIDR into smaller subnets, right? And that smaller subnets we can assign based on our how we want to separate our resources. So what would happen? We have selected our region, Mumbai. We have created a VPC 10.0.0/16. Now we know there are three availability zones in a single region. So we can assign two subnets. One is for public and one is for private. Two different subnets, and I'm using /20 here. and I have created these subnets, for AZ1, AZ2, AZ3. Now this gives me a flexibility that I can create my resource here, and it would use any IP address. For example, if I create in a public subnet from this range, if I create any resource in AZ2, it will use the IP from this range. If I create any resource in AZ3, it will use the IP from this range. Now, generally, what would happen, we should put anything which is internet facing on the public subnet, anything which should not face the internet in the private subnet. For example, all the database you should put in the private subnet. You don't want any attacker to have a direct access to your database, so it should go to the private subnet. Think of it, if I show you, yeah, let me just draw it here. So think of it, you have a you have your home, right? You have a guest room, right? And then you have your uh, maybe your bedroom. So what you do, you only allow access for the guest to access the guest room, right? So this means in the similar way, your guest room is some sort of public subnet and your bedroom is a private subnet. So here what we are doing is logically separating our resources onto the consideration whether it should be accessed publicly or privately. So anything that needs to be accessed publicly, we will put in a public subnet. Anything which does not need to access from the outside world directly, we are going to in the private subnet. For example, our database or our EC2 instances, we are going to put into private subnet. And what we'll do, we'll create a jump box in public subnet and access it from there. Is it clear, the concept of public and private subnets? All right. So this is how a VPC looks like. And as I've mentioned, I've created a VPC with name Sydney VPC. This is VPC ID which would be generated. This is the CIDR that I was mentioning about we use. And then this is all which is generated by AWS. The important part is this CIDR, right? And what is the AWS account, right? That's it. Now, once you have this created, you need to, as I mentioned, we have created the VPC subnets. We have to define our AZ subnets, a route table. Route table is basically how we want to, route the traffic. So by default, you don't need to do anything. But in case you want some custom routes, you can put in a route table. And this is how your AZ definition would look like. You have your VPC, right? Sydney VPC here. It is going to these subnets. I've created 3 subnets and each 3 subnets is in different availability zone. So AP South is 2A, 2B, 2C. So these are 3 AZs. Now all these are managed by this route table. So this is the route table, which means my current route table is doing only one thing. It is sending the traffic to my internet gateway. Okay. And it looks something like this. So it would be much more clear when you do the hands-on. But if you have a bit of internet or you can say networking experience, you would know this is all the traffic I am sending to an internet gateway. And this is my local traffic. That's it. So this is how route table or route table looks like. So we have created everything. So this is the design that looks like. So we have our region, Mumbai. We have a VPC 10.0.0.16. We have 3 availability zones, right? In 3 availability zones, we have created 2 subnets each. So one is the public facing and one is the private subnet. Any questions still here? This design, does it look okay to you? I mean, are you able to understand what's going on here? If yes, I can continue. All right, I will continue. So as I mentioned, as I showed you, we need an internet gateway, right, to send our traffic towards internet. Else it won't be able to access the internet. So we put an internet gateway here, and this internet gateway is basically allowing us to connect to the internet. So this means now, suppose if we download anything, onto our instances, we can access any public repository or any internet site, using the internet gateway. Now, we need to spin up a virtual machine, right? Because EC2 on cloud provides a virtual machine. So how we can spin up a virtual machine? We need an image. Image is basically, for example, you are using an Ubuntu image, so you will download Ubuntu image from internet. You will use some bootstrap config. For example, suppose I want to install Apache server, so that I will create a script of it, and then I will use it as a bootstrap config. And using this, I can spin up my virtual machine. Now for this virtual machine, I can also configure how many CPUs I need, how many memory I need, and how much disk I need. So suppose this is the configuration. So this is how you define your virtual machine locally. Suppose you are using VirtualBox or anything, or you can follow the same steps, right? So we need to follow the same in the cloud as well, right? To summarize, we need to spin our virtual machine. We need to decide on the image, decide on the virtual machine configuration, and then user script. So when you are working with AWS, you have a concept called Amazon Machine Image. Basically, you can select what type of, you can say, system or operating system you want to run. And for example, this is Amazon Linux, and it is 64-bit. So you can go ahead with the 64-bit architecture and you can use it. So it also provides what is the platform, what is the root device type, EBS is elastic block storage, what virtualization it supports, and does it have enhanced networking configuration enabled. So this is, you are going to understand, once you're working with it. But AMI is basically something like, suppose you have downloaded the Ubuntu image, and suppose you want to create a new system, new virtual machine. For example, you want to use Mac OS, you can use Mac OS from here. Now in VirtualBox, we can have any combination of vCPUs, memory, etc. But in AWS, they have predefined type of configuration, and they have named all this configuration. For example, if you have one vCPU, and this is the architecture type, and this is the memory, they call it as T1.micro. So when we talk about T1, T2, micro, nano, small, medium, this is called instance type. So instance type is basically what is the vCPU and memory combination, right? What is the you can say storage type, and what is the architecture it supports. There is some difference in terms of what type of processor it uses. For example, some of them will use x86 64, some of them will use ARM. So that is different. But this is just only a combination of processor, memory, etc. And then you will have a cost, how much you are going to pay when you are using this instance type. So suppose if I ask you to run a T2 micro instance, you can easily calculate what is the cost of it, right? USD per hour. And then you can calculate what is the cost for per day. So when you are spinning up your EC2 instance, you need to define a subnet. So this is the important part. So what subnet I would use? I would use the private subnet, and this is how your configuration would look like. So we'll have EC2 instances in the private subnet. EBS is an elastic block storage. This is something similar to you will have some disk associated with your laptop. For example, 1 TB of hard disk in your laptop is SSD. EBS is something similar. So you will have EC2 instance, you will have disk storage, and the question might arise: why would have a disk different, separate to your EC2 instance, right? So what happens? Suppose you terminate your EC2 instance, your data is still stored in your EBS volume. This data is not lost. So this modular approach is very helpful. And if you want to scale up the EBS volume, you can easily do as well. So that's why this storage disk is separate to your volume. So now you have EC2 instance, your EBS volume, and what I did, I created 3 copies of it, each in a different AZ and into the private subnet. Any questions till now? All right. So we are done with the EC2 instance. Now we have to spin up our database. So we can use RDS. RDS is the product. Now, whenever I'm introducing a new terms, think of it. Every service in AWS has a specific purpose. So for example, RDS is relational database. So relational database means it uses SQL. So we'll have all these database type: MySQL, PostgreSQL, Oracle SQL, etc. And when you spin up, you can select these database. And it also have some configuration just like your instance type. So now I can add the RDS instance. RDS has two you can say options. One is a single AZ and one is multiple AZ. So if you spin up a multiple AZ, what would happen? It will create a database and it is a managed service. You don't need to do anything. What it would do? So suppose it will spin up a master into AZ1 and these two would be the read instances. So this means it will give you an endpoint, for example, x.db.aws.1, whatever the endpoint would be. And what you can do, you can directly access this from any of the EC2 instance and you don't need to do anything, right? It will automatically manage. Suppose this instance goes down, it will make this master. If this instance goes down, it will make this master. So it will automatically manage everything behind the scenes, and that's why it's a managed database service. So we create a managed database service. Now what this endpoint can can be difficult to remember. So what we can do, we can map it to our website. So for example, our website was xyz.com, right? So we can create a db.xyz.com and then map it to the endpoint provided by this RDS. Now we can reference directly by db.xyz.com. And where we are going to do this in a service called Route 53. So Route 53 or R53 is the DNS service. It's a very simple DNS service. So DNS is basically you map some entries. For example, you will have a host name and then you will have an endpoint. So this endpoint can be an IP address as well, IPv4, IPv6. So in case of IPv4, we will have A entry, and for IPv6 we have 4 times A. We have C name. For example, we want to have a name 1 map to name 2. For example, here we are going to use C name or canonical name. Canonical name means I can have db.xyz.com map to whatever internal endpoint address AWS has provided me for this RDS. Okay, so it's easy for me to remember where my database is located. Any questions? So I created this an entry in my Route 53 DNS service. So Route 53 is the DNS service. Now we can also go for DynamoDB. DynamoDB is a fully managed NoSQL database. So it's a NoSQL, as we talked about in the previous example of NoSQL. We had Cassandra, etc. So you can use DynamoDB is the corresponding component in AWS. So it has also some configuration, and here you create tables. You don't create database, you create tables. So you have a table name, and then you have a partition key and then sort key. So think of partition key is the primary key, and then you create the table, what type of table you want, and these are some of the terms related to DynamoDB. So I have split up my database. So DynamoDB is a global service. You don't need to attach it into VPC. So it will give you a table name and you can access it, right? This is my architecture with AWS, right? Right now, my EC2 instance, if I put any code, it's still not accessible from the internet. So what I will do, I will add a load balancer, right? So in load balancer, you have an option in which availability zone you want to serve. So as you can see, I have selected all the 3. And once you do that, it will create target groups. Target groups means you can attach what EC2 instances I want to do traffic to. And here I have created a load balancer and I have specified, okay, you need to send traffic to all the 3 EC2 instances. So load balancer will also have a endpoint, for example, load balancer.xyz.aws.com. So we also need to add a Route 53 entry so that it is easily we can easily remember it. So what we do, we add a Route 53 entry, and what we do, we put the primary domain name xyz.com map to load balancer. So now my website is accessible, right? My database is connected and I'm able to serve the traffic. But as I mentioned, in case the traffic increases, we need some way to scale this horizontally, right? To scale this horizontally, what we need is term called automatic or auto scaling group. So auto scaling group can use metrics from CloudWatch. So think of CloudWatch. It's a very logical term, right? CloudWatch. It means it is watching something in your cloud in AWS specifically, and this means it is checking the metrics. So with metrics, for example, we can set a metric. For example, CPU is greater than 80%. So as soon as the CPU usage hits 80%, it will spin up one more EC2 instance. And we can scale up on a region basis, or sorry, on an availability zone basis as well. So we can have, maybe I can maximum have 3 EC2 instances here, and as soon as the next one will increase, it will spin up one more depending upon how much we have maximum specified. So it has a configuration called min, max, and desired. So means for example I say 3, so this means 3 1 1 1 in each. Max I would say 12, then it means 4 into 3, right? 4 is EC2 instances in each AZ. And desired I would also say 3, that desired is 1, right? So in case there is a low traffic, it will always keep this configuration. So you can change desired anytime. Suppose I want to go and scale up on my own, I can change the desired configuration. So if I make it desired, for example 9, it will just currently make 3 instances in each AZ. So this is an auto scaling group. And auto scaling group works on metrics, and that matrix is provided by CloudWatch. Okay. So we have CloudWatch. Uh, so we scaled up our EC2 instances, but what about our databases? As I mentioned, we need some sort of caching. So we can use Elastic Cache. So Elastic Cache is the database caching capability of AWS. So it uses same Redis or Memcache. And once we have these caching enabled, right, we can also offload our static content that we actually put into Google Drive or Box, etc., right, into an S3 bucket. So this is called an S3 bucket. So S3 bucket means it provides you the object storage. You can put images, you can put video, etc. So with S3 bucket, you probably would use some sort of content delivery network, CDN, and that is Cloudfront. So this is Cloudfront, and we can map it with here, for example, cdn.xyz.com. So what would happen, for example, I will store some videos. It will serve to the local, you can say, point of presence that I've talked about before. And then with this, we can also use some global services. For example, if I have more, you can say, employees to manage my website, I would use IAM to provide permissions. So IAM is identity and access management. And then I can also use CloudTrail logs. So what is CloudTrail? Basically, it will record all the access of services, etc., and store it into an S3 bucket. So we can store it into an S3 bucket, and we can use Amazon Athena to query it. So these are the services that we can use in our AWS environment. So I've talked about EC2, EBS, RDS, DynamoDB, Route 53. This is CloudWatch metrics, CloudTrail, IAM, S3 bucket, Amazon Athena. Then you have Internet Gateway. Then you have Load Balancer. Then you have S3 bucket. You have CloudFront, which is a CDN service. Then you have VPC. Now, if you want to connect to VPC to another VPC, you use some sort of mechanism which is called VPC pairing. So that's the AWS services overview, and I hope this is clear. Any questions as of now? I think we are almost on time.